Welcome back, Kerbalats. Today we're going to launch a new satellite into space. We have an infrared camera here on the top. We also have a atmosphere sensor. I would go ahead and run that, but we don't really have enough power. We have our standard instruments too. What we're going to try to do here is to get into a couple of different orbits. You can see one polar orbit and one that's another geosynchronous orbit. We're going to do the geosynchronous first, and then we're going to go into the polar orbit. The reason being is it's cheaper to change the planes when you're further out. That is an interesting orbit. It's going to possibly run to the moon or something interesting. We could probably use the moon to make it easier. Okay, so we're going to launch into this one. Check our launch window. Where are we? Yeah, looks fine. Let's go ahead and do this. So this is a little bit bigger than our previous rocket stage. It's going to fire off not quite as fast, but hopefully, unlike the previous time that we tried to launch a rocket, we should be fine. We should be able to. We have a greater than 1 thrust to weight ratio the entire time, unlike our last one that we didn't at the top of our orbit, and it took forever and we lost a lot of fuel. So, lesson learned. I'm gonna start our gravity turn here. Well on our way. So you can see we have a thermometer and the new probe with a thermometer. So we just have to reach the right orbit and we'll be good on both accounts. We need to start taking our turn here a little bit more seriously. One of these days we'll get an aerodynamic shell, but we don't have it now. I'll run the atmospheric scanner in the upper part of the atmosphere and we'll find a time when we can transmit that data. It's a lot of data for a relatively small amount of science. That's not good. Wow, I cannot believe that worked. So we lost a little bit of efficiency, but it'll be fine. It has actually happened that a rocket has done flips like that. Not orbital rockets, but I've heard of instances that rockets have done this. This is not good. Oh, we do have some thrust vectoring on this. Come on. Come on. Oh, we have the reaction wheel. That's how we're able to control. Pretty good control too, really. So we're fighting the atmosphere here because we don't have a shell and we're moving at past the speed of sound, so this is a very awkward shape. Come on. Okay. Now that's a little bit steadier. We'll just keep on burning like this until we get outside of the atmosphere. Hopefully we didn't lose too much efficiency and we can still manage to pull off both these missions. This is why aerodynamic shells are always used in missions like this. Oh, upper atmosphere over the water. Interesting. I didn't realize it was that specific. Still have plenty of fuel. I didn't put my Kerbal engineering readout. I should have done that, but we should be fine. So we're gonna keep burning until our apoasis is actually, we want to hit the ascending node at our apoasis. And so we'll do a circular insertion orbit. Do a standard Kerbal Space Program orbit here. Which of course is not very standard at all. I've suspected the super secret Zuma mission. I kind of wonder if it did some kind of an orbit like this based off of what little information was available. But it's really hard to say. Not a whole lot of information is known about that mission. Not to the general public. I certainly don't have any inside information on that. So we are in space. Yay! Be in orbit here soon. Yeah, close enough. Okay, we want to hit the descending node, so let's burn right about here. This is actually not that different from how you would approach getting a satellite into orbit for in a real mission, although you would launch at the right time of the day such that you were already kind of in this plane. We're not. It's one of the reasons why some missions have some fairly tight launch restrictions. They're a lot looser for a commercial satellite than say something to the International Space Station that has a very, very short window, but most commercial satellites do have some kind of tight restrictions in this for this kind of stuff that they're doing. They want to. This is a very realistic thing that the satellite company would say, hey, this is the kind of orbit that we want to be in. We don't really care what point in the orbit we are, unless you're headed to the space station. And the satellite has some fuel on board and they can do some correction. So they will do that when they get into orbit to do the final burn for the most part. But anyways, there are a few missions that want to be directly put into their orbit and don't have a huge amount of fuel. In particular, one of the more famous ones, the military sometimes wants the ability of a rocket to put a satellite directly in geostationary orbit, similar to what we're doing right now, actually. So that looks pretty decent. Alright then. So let's see, the point where the two cross. It's right here. See how they're lined up, both the yellow orbit and the cyan orbit, our target orbit and the orbit we're in. So we're gonna add a maneuver at that. Got the wrong node, whoops. Just eyeball it. How close are we? Yeah, close enough. Okay, so we're going to add Wow, why do I have so many moves? Ah, whatever. Okay, first thing, we're descending nodes, so we're going to raise our inclination a fair bit. You see, it doesn't take nearly as much fuel. Real missions, might even go out past the orbit, because sometimes you can save a lot of fuel by doing your inclination adjustment as high as you can do it. The higher it is, the less fuel it takes. It's basically related to the fact that you're moving slower when you're that far out. Yeah, we'll keep burning a little bit more. And a little bit more ascending. A little bit more out. A little more ascending. Yeah, I like that. And then we'll just do a little bit of polishing to finish her off. Okay. So let's put it in position. See if we can do anything with this. Infrared telescope can't be done right now. Oh, you have to put it in the sun orbit. Ah. Well, maybe we'll do that at the end. I don't know. We're gonna wipe out our electricity. Ah, that's too bad. I don't know if we'll be able to transmit the atmospheric data, and it doesn't seem to let you do it a little bit at a time, which is unrealistic. It actually makes sense the infrared telescope would have to be in a solar orbit. That's where we tend to put our infrared missions in real life, because they're far enough away from the Earth. The Earth can kind of interfere with the infrared that is sensing objects basically by their temperature. Well, let's just go to map mode and warp to get kind of close. Let me try that one again. See, our speed is slowing down here, and basically the inclination, you're changing your speed sideways, and the way that things add up, it's much more efficient to do it when you're on the furthest point of your orbit, which is why we're going to do it here. And actually, once you've come this far out, it doesn't take a whole lot of extra fuel to completely, put yourself out to this orbit out here, for instance. You'll see we'll do a massive inclination change once we get out here, and it's not going to cost us very much at all. Assuming we have the fuel, do we? Yeah, we might. Or we might have to launch another mission. Some of those little loop-de-loops were not very efficient. How close are we? Well, what's our descending node 0? That's good enough. Alright, so we gotta finish circularizing this. We're gonna do this in 2 burns. We're gonna do this one at the proposed apoasis. We're gonna get it to just barely touch that orbit. We want to touch the periapsis if we can do it. It doesn't look like it's going to want to let us do it. Okay, whatever. We'll get it figured out. It might take us 2 or 3 burns, but they're not going to be very big ones. You know, this company's wanting to get its satellite into position so it can make money. But, you know, they'll have to hold their horses some. Okay. This is just going to be a tiny, tiny burn. So it should be just fine. Just barely going to touch it. One of these days we'll have to do these temperature readings here. But not a big deal. Maybe I'll launch something that looks kind of like a space shuttle to go do those. Close enough. Okay, we are touching. So at this point that we're touching, let's... Oh, did we complete? Ah, I guess we're close enough. Nope, we're not. Huh, I don't know what that was. Okay. We will be in one more burn though, for sure. Yeah, that'll take it perfectly. Okay. So let's just hold off until we reach that point in the orbit. So there's 3 different parameters basically that tell you the kind of orbit that you're in. The inclination is the big one. So the inclination just happens that Moon is at a 0 inclination. That means it orbits right above the equator. This blue orbit here is a polar orbit. It's almost perfectly 90 degrees, so it'll go over the poles. And this one is, I don't know, like a maybe 10, 13 degree inclination, something like that. I could have checked if I wanted to, but it doesn't matter that much. So that's one. It's fairly well known. One that's much less known is the orbital plane that you're in. So I could be in a 90-degree inclined orbit, and I could be completely different than the polar orbit that it's going to try to get me into. I'll show this off in a minute. I don't think it's going to be 4 seconds. Ah, what am I? What is going on here? Huh. Kerbal is not wanting to take my... It must have some weird UI thing going. Well, I'll just burn attach. Sorry about this. I don't know what's going on. This is very, very odd. Well. Well, that was lovely. Cannot delete maneuver null. Control locked. Oh, this is not good. Am I out of power? I'm out of power. We're just gonna have to hope that the solar panels get a little teensy bit of charge. That's all it's gonna take. And then we'll spin this. Until we're getting some more charge. Yeah, satellites don't work very well when they don't have any power. This is bad. I should have spun it. Well, let me just zoom till I get a little bit of power collected again. It'll be nice when I have better solar panels and I don't have to worry about this as much. But these panels are just fixed. Come on, I just need a tiny, tiny bit of power. That's all. Oh boy. This kind of stuff can happen, and it's something that's a very, very real concern in satellite missions. I kind of suspect this is one of the reasons why satellite operators like to deploy as quickly as they can, because they're less likely to run into these kind of power issues. You can't deploy your solar panels until after you've been released from the rocket. Oh dear. I seem to have made my situation even worse. I am not seeming to get any power at all. Well, this is a bummer. All we need to do is just to rotate the spacecraft a tiny, tiny bit and we'd have solar power. But we don't seem to be able to do that. In real life, the satellite, if it died like this, it would eventually start tumbling. And it would eventually get power. It's actually very, very difficult to deliberately have a satellite that doesn't have any power permanently. But it seems like we have a stable orbit that doesn't have even a drop of power. Lovely. Well, we got a dead satellite on our hands. Still have a fair bit of fuel. Maybe we'll be able to come up with something. But I think I'm gonna take a pause real quick and I'll see if I can come up with anything that will help to get it a little bit of juice, just a teensy bit. So I'll see you in a moment. Welcome back. I was able to get just that teensy bit of electricity, get it into a much more stable orbit, and we're going to give this another shot. Why am I moving so slow? Oh, I don't want to warp to next maneuver. I want to just warp to this point in orbit. Whatever. Basically, I'm clicking on the wrong line, but it's virtually impossible to click on the right line. So I believe once I hit the same maneuver point that I should be able to, yeah, use the same maneuver that we'd planned before. This time we gotta be... Nope, that's not gonna work, but we can just eyeball it. Oh. Just have to maintain our stability, and there we go. We are successful. Yay! Whew. That was a rough one. Okay. Now, how are we doing with our power? Perfect. So now we're going to take it out. Oh, perfect. We have a flyby of Mon. Trying to decide how worth it is to take advantage of it. And the answer is it is worth it. We have the potential to save a ton of fuel, and we don't have a lot of fuel. Okay, so it's right now it's not really saving us anything, but we're gonna try to correct that a bit. Let's see if we can pass more over one of the poles. Whoops. One thing I forgot, we gotta make sure we're going in the right direction, so we have to be going down. We actually want Mon to be right there. We're actually intersecting it, which is perfect. We want to fly right over the top. You know what? This isn't really going to work. But it will help. Although we're not going to go quite as much. So remember how I said that inclination changes are better the further out you are? Well, we're going to put that to the test. Boy, are we going to put that to the test. Okay. So let's warp to the next maneuver. Actually, let's wait for a few seconds. Yeah, I'm gonna cancel this, I'll just do it. I'll eyeball it. Should be getting, there we go. Actually, we're gonna do another maneuver here. See if we can improve this any. Actually, we're just gonna keep burning prograde until we're no longer. Right now, we're intersecting the moon. We don't want to do that. And then we're also gonna leave the Kerbal system, which we also don't really want to do that yet. Okay, this will be perfect. So we're gonna get a nice flyby of the moon, and then we're gonna head out into deep space. And by deep space, I mean almost out to the orbit of Minmus. Alright, let's just go ahead and do our normal check here. Actually, we're just gonna warp. I can't use auto warp so far out. Because we're passing so close to the moon. It's gonna... Let's go ahead and auto warp through to the moon. Hi, moon. Because we're flying at such a weird path, it is changing our inclination a fair bit because we're going over the poles. But we're not taking full advantage of that. It would be difficult to do it from the perspective that we were. Let's go ahead and add a maneuver out this far. Did we lose power again? Oh, man. No. We have power. Control locked. Where's my antenna? This is bad. Well then, so we're out of radio contact right now from Kerbal. We don't have a proper antenna to be able to talk this far out. We got nothing at all. Well, that's what I get for not putting a bigger antenna on here. Okay, well this satellite is going to be a piece of... Well, hang on, there's one more thing I can do. If you can't make the antenna bigger on your satellite, there's one other option you can do, and that is to make the antenna bigger on the ground. So let's see if we can upgrade our tracking station here. Ooh, that's expensive, but okay. Whoops. Wrong button there, so we gotta go back to tracking. And hopefully we'll have some control. Fly. So we made the antenna on the ground bigger, which will also improve our link budget, but doesn't look like it did a good enough job. We still don't have any control. Alright then, we'll have to set up a relay satellite, and we should be able to gain some control over this, or I don't know what we'll do. The link budget is real. You really got to pay attention to that, or else you can get burned, and we did get burned. There's all kinds of complex calculations that go on to determining a satellite. When I was a student, I built some satellites when I was a college student, and in order to test them out, we had an attenuator that would make the signal appear weaker, and then we would broadcast the signal through the satellite and see if we would be able to talk to it when it was in space. Invaluable to do those calculations on the ground before you ever launch, so you don't run into this kind of a problem where we have a expensive satellite that is not able to do its job. The good thing is the satellite at least did one of the jobs that was assigned to it. It just could not do the second one. Oh well. We were still somewhat successful, and I'll figure out another time to get this polar orbit satellite in here. But thank you much for joining me. Let me know whatever questions you have. Also, let me know if there's any suggestions for other games that you would like me to do a review for their realism. I have at least one other game that's in the works, but I'm really curious if there's anything else that you would like me to do, because I would want to help you guys learn more about this kind of stuff and how realistic these games are. And thanks for joining me, and we will see you next time. Take care.